Infotech. Hello everyone and welcome to today's webinar session hosted by Magna Infotech Care Services. Magna Infotech Care Services is a learning platform aimed at bridging the gap between one expertise and growing industry expectation. The prime objective is to provide IT skills training to individuals, aligning them to the skill sets that are most sought by organizations today, while also preparing them for future industry trends. This webinar provides a brief overview of DevOps and tools one must know and would be useful to a wide range of professionals. Leading organizations across the world has adopted DevOps methodologies to overhaul their performance, security, and team dynamics. With more and more companies jumping onto the DevOps bandwagon, it has emerged as a highly sought after skill to master. I take the pleasure of introducing the speaker for today's session, Mr. Nihant. He is an expert in the field of DevOps, Kubernetes, and Docker. He has 9+ years of industry experience along with 4+ years of training experience. Thank you. Over to Nihant.
All right. Hey, welcome everybody. My name is Nishant, as you know, and it's time we get started. So this webinar is all about understanding DevOps, what do you mean by DevOps, and what is it that we do. Now, right before we begin, can you please confirm that you can see my screen and you can hear my voice without any problems? So yeah, thank you, Tarun, Anil, and Pawan Kumar. All right, great. So let's get started. Today we are here to talk about why there is so much of demand in DevOps. What is it that we do, and what is it that we work with? Now, I have been personally working as a DevOps engineer for almost 10 years. So I do have first-hand knowledge as to what production environments look like, what is expected from us, and what is it that we do every day when we are in office, right? So if you are employed somewhere and your organization does happen to have, a sort of a DevOps team in your office, the chances are the way they look at DevOps will be a lot different than the way other people look at DevOps, because it's a really big umbrella term. It does cover quite a lot of topics, and everybody interprets DevOps depending on what is it that they are focused on. So we'll try to iron out a few misconceptions. We'll try to understand what do we do as DevOps, and I'll try to give you a few examples as to what is it that I do every day, which is something that will help you make sense of what can you expect from DevOps. Right, so that's a bit about me. I'm pretty sure the introduction is done already. Now, agenda for the day is demand of DevOps. Why do we need a DevOps engineer? Which is, a funny agenda. I'll get to the reason why. Demands of a DevOps engineer. Who is a DevOps engineer? Roles of a DevOps engineer. Skills required to become a DevOps engineer. The learning path that you might want to employ. Course curriculum. And at the end, it'll be about the benefits. Now, the very first reason is, or the very first agenda is, demand of the DevOps. Why is it that you see so many jobs available for DevOps, and why is it that you never see those vacancies going away? Like, even if you go to some job portal, you'll see a lot of openings for DevOps. You check the same job portal a month later, they will still be looking for a person. So if there are so many jobs, why aren't people getting employed? Not audible. Okay, can you hear me now? A couple of guys saying you are not audible. Or it's just the one person, I don't know. Can you guys hear me? Yeah, okay, so maybe just one person that had some network issue. All right, so why is it that you think you've seen some opening? You go back to the same link like a week later or 10 days later or a month later, you'll still see that open. So why is it that there are so many jobs but people aren't being hired for it? There are very specific reasons for this. Now, before we continue, right, the previous slide, I said I found something funny in it. The reason is that technically there is no such thing called as DevOps engineer. If you call yourself a DevOps engineer, it basically means you don't really know what you're working on. Now, this is the term that the industry came up with. we work with so many tools, so many technologies, and so many languages in general. When the HR people, they contact us for the job that they have, they don't really know how to explain what they're looking for. So they came up with the idea of DevOps Engineer. Now, the community, like us, who are working as DevOps folks, or we are also called SRE, Site Reliability Engineers. So we kind of pushed back on it. There's no such thing as DevOps Engineer. Why are you calling us a DevOps Engineer? But eventually we gave up because it was making the lives easier of the other people. So they would just call us, hey, would you like to work as a DevOps engineer? And now we're at a point where we don't even argue. We simply argue like internally, inside the technical group. But anything outside of it, we don't even debate the point of DevOps engineer. But ideally, there is no such thing as DevOps engineer. DevOps is a set of principles, is a set of ideas of having a perfect or the most ideal environment, depending on the stack of the application, right? So we'll get to the part of demands of DevOps. So cross-team collaboration, agility, or why is it that DevOps is so much in demand? Now I'll give you a side of what I do. I'll give you an aspect of what I do every day, which is the reason why my employer or the company that I'm working with, that finds me desirable, right? So imagine this. Let me quickly open a notepad so I can just kind of scribble a few things that will help you make sense of it. So imagine this, an organization, any organization, would mostly have a development team, that does the development, and then it would have, if you're working with some data science company or some machine learning company, they would tend to have an analytics team, which does the report generation, number crunching, and those things. And then you would have a production support team or ops team. You might call it something else, but at the end of the day, they are the same teams, right? So let's call it an ops team. And then you have a finance team, which has nothing to do with technicalities, but they are the ones paying the bills of all the resources that we use, right? Now the problem is, analytics guys would have no idea about development. So analytics, while it does touch upon a bit of programming, but that's more about number crunching. That's more about writing scripts that will give you some sort of visual results. So this is not really development. Development, on the other hand, don't really know analytics, because analytics is more about algorithm and maths and those things. So developers won't really know about analytics. At the same time, ops has absolutely no idea what's going on in dev as to what is development. You pick up any Linux administrator that you talk to him for a minute, and you ask him, if I give you a task, can you code this for me in Python? And the answer would almost always be, no, I don't really know coding because that's not my job. They might know a bit of shell scripting, but that's a completely different story. So ops would not really know about dev, forget about analytics. And then there is finance, which has absolutely no idea about analytics, dev, or ops. Now this is what has been happening throughout the inception of application deployment or IT in general. Now in today's world, this can't really go on. When I say this can't go on, right, it's not that I'm pulling these things out of thin air. Think about companies like Netflix. Think about companies like Uber. Imagine if you're working with Netflix and something is not working, and you are working for a platform that is consumed by millions of people around the world, billions of hours of video streaming every single day. So do you think you have an option to say, I'm sorry, I don't know what's going on? That wouldn't work, because if that's your answer, that means the company is going to go bankrupt on the very next day. Not so much in the case of Netflix, but think about something like Uber. You booked a cab on your phone and suddenly the application stops working. Are you ever going to use Uber again? Specifically if that ride was really important to a hospital or something? Never, right? So in today's world, you can't really have a platform where you have isolated teams in their own silos. When I say silos, what I mean is developers are usually happy with whatever they're working on. They don't really care about what the other teams are doing. Ops people are really happy with as long as their servers are up and running. They don't really care about what happens with the code. Now, these are the things of the past. They don't really fly in today's world. Well, so where do I fit into this entire picture? Well, where I fit is right in the middle. That's where I am sitting. That's where the entire DevOps team is located. So what we do is we are part ops, we are part dev, and I'll explain exactly what do I mean by part ops and part dev. So majority of my team, the team that I handle, majority of my team knows everything there is to know about infrastructure. When I say infrastructure, I mean everything about ops. Like, all kinds of servers and networking and databases on the cloud, on premise, everything that you can think of. Also, we might not be hardcore developers, but we are good enough to create the system tooling. Now, when I say system tooling, what I mean by system tooling is I'll give you an example in a while, right? So it's not like I have an option to say I don't care about the code. That's not an option. I have to know exactly what's going on with the code. Where is the development team? When are we expecting to release some feature that we are working on? Do I have the platform ready to consume the code that these guys are working on? Not only the code, I have to make the lives easier of other people. To case in point, let's say my developers are working on a Java application. Now you can replace Java with any language that you guys are working on, right? Now let's say they are working on Java application, and the process looks something like this. So the moment they give me the code that they've written in Java, I'm supposed to compile the code. And once this code is compiled, I'm supposed to, perform some sort of tests and checks and balances on this code. Once that is done, I'm supposed to package this code. Now this package could have been done like anyway. Java, it's a Java application, so you directly get a WAR file, or you can also use something like Docker. So let's say this is what happens the moment I receive the code. After this code is actually supposed to be deployed in production. Now this is an entire workflow that takes anywhere between 5 hours to 4 days, depending on how busy we are. But again, that can't fly in today's world, right? Because these guys cannot sit idle for 5 days waiting for us to do our job. What I can do is I can create something called as a CICD pipeline. Some of you might have heard of it, but basically what this does is it automates the entire process of application deployment. As soon as they push their code to some central repository, it could be any repository. It could be Git, it could be SVN, it could be Team Foundation, anything that you guys are working on. As soon as they push the code, all of these things will be done automatically, and the application will be deployed in a temporary environment where somebody can quickly check it out and decide if we want to release it or not. Now, this can also be automated, but the whole point is, instead of waiting for like 2 days at the minimum for us to do our jobs, they can simply push their code, give it like 2 minutes or 3 minutes tops, and they have a fully working application that they've been working on. Instant feedback. So in this case, they get the results in like 3 minutes. Whatever I did, is it working? Do I want it? Do I want to change something? Or is it good enough to actually be deployed in production? So this is just one wild example, all right? I'm not trying to get into specifics, but I'm simply trying to show you how do we solve the problem of people. Now, when I say CICD, it's really easier said than done. There are 100 different problems before you actually reach to this stage. But how do you tackle those problems? Are there any tools available that can help you tackle those problems? Or there are no tools and you need to create one? All of those are our responsibility. Now, that's what I mean by system tooling. So in majority of the cases, right, most of these problems are already solved. So you don't really have to reinvent the wheel. But in very rare case, when there is a problem that's really, really specific to your organization, you might have to spend some time actually working out on a tool that will solve the problem. So this is one example. Another example would be, let's say, analytics, number crunching, right? So they run some sort of report generation, and as an example, on every Saturday night, they get a full report which gives them more visibility about whatever we are working on. So let's say we are a marketing company, we are an advertising agency, and they run some numbers which basically tell them, do I want to advertise this product to what age group? So the report says you want to advertise this product to the males located in Bangalore between the age group of 18 to 25. That's what this product is suitable for. Now they want this report every week, right? Now they have to walk up to me every week. Nishant, did you run our scripts? Did you get the report? Can we please get access to this report because that's important for us? Now instead of them calling me and walking up to me every Saturday, what I can do is I can set up another automation flow which will do everything that the report generation was supposed to do. And at the end of it, when the actual report is generated, it will be emailed to them. Now, I am not even in the picture once this is in place. they can be served by themselves. Now, an example of finance would be, let's say if your company uses something like AWS or Microsoft Azure or something, some other provider. Now, every month, they come asking you the questions. Nishant, we are spending $30,000 a month on AWS. Why are we spending so much of money? Can you tell us where the money is going? Now, every time this dude walks up to me every week, Nishant, this week our bill or our invoice is $10,000. Where is like 7 lakh rupees going per week for infrastructure? Well, here's the thing. Here's our AWS account. Here's a script that breaks down the entire expenditure that we have, and this will be emailed to you every weekend. You can look at the money that we're spending, and if you think it's not justified, then you can get back to me. So I hope you're starting to see a pattern that's emerging. My basic job is to make sure that everybody can get their job done. That's what I do. Now, when I say my job is to make sure they can work, I'm not really talking about support. A lot of people misunderstand DevOps for production support. I'm not really your support. I'm helping you to enable yourselves. I'm helping you to do your job faster and in a more seamless way, so that you don't really have to run around on 10 different desks asking for what is it that you actually need. Make sense? I hope you guys were able to hear me, right? And one thing, during this webinar, at any point in time, if you have any questions, feel free to ask me the questions, because I'm a firm believer of asking the question is the way to learn things. So if you have any questions, feel free to let me know. And I hope whatever I'm discussing is making sense. If you're working in a company, more or less you would have faced like some of the other problems in the environment that you're working with. Now, just bear with me for one moment. I'm trying to figure out, yeah. All right, cool. So you guys can hear me, right? Because I have like 2 people complaining they can't hear me. So I don't really know if it's a problem with the webinar or you guys can hear me. So can you please quickly confirm that I'm not talking to myself and you're actually able to hear all that I'm saying? Guys, yes, no, maybe so. Kind of interesting. Nobody said yes or no. So now I'm confused if you can actually hear me or not. Okay, now people are saying they can hear me. All right, thank you. Okay, cool. So that was a really basic idea about what I do. See, there is no way that I can actually explain the technicalities, because I've been doing this for 10 years, and none of what I do is simple enough technically to explain in 10 minutes. I'll try as much as I can, but I'm trying to give you an insight as to what is expected out of you, what exactly it is that you do. So right now what I told you was a very generic information. We'll try to get a lot more direct, as and when we progress with the webinar. So that's why there is a demand of DevOps. We basically enable a company to achieve the best possible results that they can get. Now, what I talked about was kind of theoretical because, I was drawing on my screen, but all of this is totally technical. Don't misunderstand my statement as this being more of a management job. This is not a management job. This is totally technical decisions, and you need to have like good amount of exposure to the majority of the tools out there to decide the one that works the best for your organization, right? Now, considering all of these arguments in mind, that leads to the demand, or such a huge surge in the demand of DevOps engineers in today's world. I mean, I'm no longer in Bangalore at the moment, but I'm pretty sure there are still like hundreds of DevOps jobs open in Bangalore. I still get a job. I still get a call like 5 times every day. Nishant, do you want to join us? But there is a reason that there are companies looking for it, right? So cross-team collaboration, agility, code is deployed 30 times more frequently, the continuous delivery part, reliability, and 50% fewer failures of new releases. Now, I don't even think this 50% is the correct number. I would bet my life on this being lower than 5%, at least in an environment which is matured with DevOps ideas. If a company has been adopting to the ideas and working on them on like more than a year, I can guarantee that this would be like less than 10%. Cool. Now, need of the DevOps engineer. This is a case study. So, case study of Alice. Alice is a hotel management application that provides SaaS. Alice tracks every guest request, whether through the mobile app or website, in person, over the phone, or SMS. So, basically, an application that would let you book a hotel from their website, from their application, over the phone call, or via text message. Now, the problem is they had a monolithic application and did not have the solutions for continuous integration and continuous deployment. For those of you who don't really know what do you mean by monolithic application, think about any application, let's just say some banking application, some insurance application, as you would have seen them like back in the day. What used to happen was people would create an application which will be really huge. Everything that you see, everything that the application is supposed to do will be like just one big chunk of code. It will do the front end, it will do the back end, it will do the DNS routing, and everything else that you can think of. So one big application that does everything for you. Now this might sound like a really tempting words, but this is the worst possible scenario, because in that case you have a single point of failure. Something breaks in your application and the entire application stops working. In comes the idea of microservices. Some of you might have heard of microservices before. Essentially what microservices mean is that you break down your entire application into smaller chunks of features. To give you an example, right? Let's think about Amazon.in or Amazon.com, where you can, do your shopping and order the products that you like. Now, when you visit Amazon.in, right? For you, it's a very simple website. But have you ever thought about the scale of end users they have? The people that visit the website every single day, even if they're not ordering anything. So the scale is really massive. For you, to the end user, it's just a single website, but the underlying architecture is completely mind-blowing. So when you visit Amazon.in, right, let's say I open my browser and I go to Amazon.in, you're actually looking at something called as front end. That's the front end of Amazon.in. Let's say, for example, you're searching for a gaming laptop. You just want to see what kind of gaming laptops are available in the market. So you go to the search bar and you go for, show me all the gaming laptops. Then what you're looking at, the entire list of gaming laptops, is not really a front end anymore. Internally, front end has moved you to another service that's called catalog. Now, let's say you decided the laptop that you wanted to buy. So you click on buy now or add to my cart or whatever option that is. Now that is called shopping cart. I'm naming these things because I want you to understand that these are all different services in the underlying architecture. Even if they work together and make that one single website, the underlying services are completely isolated. It's not one application. So let's say you clicked on buy now. Then you made your payment, which is called a payment processor. After you made your payment, you receive email confirmation, you receive text confirmation, and then you receive constant updates, right? Like this is when your product will be delivered, your product is out for delivery. So in that case, they will have email notification services and text notification services. So these are all, although the website itself is a single application, the underlying code is broken down into smaller chunks. You might have a question, Nishant, why? I mean, what's even the reason for this? The very first and primary reason is, let's say my developers were working on some feature for my text notifications and they ended up making a mistake and that part is broken. If this was a monolithic application, the entire website would have been down. But because this is a microservices architecture, only my text notification would not be available until we fix it. Meanwhile, everybody can still visit my website. They can still place the orders. They can still pay me for whatever my products are. So the idea is to not to have a single point of failure. Now, this is what developers came up with. Now, these are the development concepts, right? So not something that we actually code, but something good to know. So these are this is more of an evolution from the development standpoint. At the same time, we, the DevOps guy, were working on the evolution of the infrastructure. Now, how did that happen? We'll talk about that in a moment. So in this case, these guys had a monolithic application. They did not have any kind of continuous integration or deployment in place. There was no automation, which was leading to all kinds of problems. Eventually, they came up with the idea of continuous integration, infrastructure automation, and then everything was fine and dandy, right? That's what the example is trying to say. But I will be more inclined to give you like a real world example instead of simply reading off of a slide, right? So what do you mean, right? When you say this company had no automation and now they do have automation, now everything is fine. That might sound magical and funny at times, because that's not how things happen, right? If it was that easy, why isn't everybody doing it? Why are people still trying to hire DevOps engineer? Because it's not easy. It requires a lot of focused effort, and it requires people who have exposure to, real world problems. So the same thing that I was talking about, right? Amazon came up with microservices, which is a completely different architecture. So what did we do? If developers did that to solve their problem, what did we do? Well, initially we had something called as, let me actually get this off. Let me get the notepad. So initially, like back in the day, what we had from the ops perspective, what we had was something called as bare metal Linux or Windows server, right? Just one server and you deploy your application on it, everything is fine and dandy. With time, we realized this is not really going to fly, because if the server goes down, I'm completely out of my application. This is not working out. Then we came up with the idea of virtual machines. We said, hey guys, you know what? Can we not just create like 3 virtual servers in this virtual server and have 3 completely isolated environments, so that even if one of my machine is going down, I still have like 2 more VMs. And the best thing is it doesn't really affect my host server, which is where all of these things are hosted. And people were, yeah, this is a great idea. So let's do this. With time, we realized while this does solve our problem, this demands for a lot of resources. So in this case, you have 4 operating systems on one server. You have, so I'm talking about Linux because Linux is my primary operating, it's the one that I work with. So in this case, I have a Linux operating system as my host operating system, and then I have 3 servers with Linux on them. So in that case, I actually have 4 operating systems, and I need like 64 gigabytes of RAM to run this server. So with time, we realized that 64 gigabytes is too much to host one application. What can we do? Well, here are Docker containers. People came up with something called as Docker containers, which work almost like virtual machines, but they are really lightweight because they don't really have a full operating system. What they have is something called as file system. Now, without getting into the details of file system, what it did was, instead of me requiring 64 gigabyte of RAM, I can do the same exact thing with 1 gigabyte of RAM. And I'm not even joking. It's that lightweight. So this helps us host our containers. And once we got to this part, we were also working on infrastructure automation. Well, how can I create 1,000 servers at the same time? If I have 1,000 servers, somebody joined my team, I need to create that guy's user account on all 1,000 servers. How can I do that? So we came up with all kinds of different solutions. What were those solutions? What are the tools? I'll give you a name of a few tools in the future. But this is how we evolved from DevOps perspective. Microservices was the perspective of the development, right? And how do I know this? Because I'm the DevOps guy. I'm supposed to know the both parts of the word. If I don't know that, then I can't call myself a DevOps person, right? Otherwise, I would be an ops guy who can manage the servers. Cool. So they meaning Alice, required a DevOps engineer. Again, I keep saying DevOps engineer when I initially said there is no such thing as DevOps engineer, because now we've actually come to terms with that, that analogy. We are like, okay, you can call us whatever you want. As long as you pay me and I have my job, I don't mind whatever you call me. So it made other people's lives easier to call us DevOps. So, it was just to let you know that there is no such thing, but it's still a title because that's how the industry rolls, right? Now, demands of a DevOps engineer. HP built DevOps solution using relevant tools. Now, these are some big brands, but I'm pretty sure if you're a part of this webinar, then you already know what is the demand like. Otherwise, you would not be spending like, an hour here. You would be doing something else. So I'm pretty sure you already know why you're here. So I don't need to revalidate your, your requirement, your understanding as to what is the requirement. Now, who is a DevOps engineer? I think I kind of gave you a good idea as to what I do. I'm yet to go into specifics. I've kind of just told you what I do. I haven't really talked about any tools. So I'll do that in a moment. I just want to make sure that we don't miss out on any other topic, right? So roles of the DevOps engineer. Maintain the code base with version control. I'll explain what each one of these things are if you don't understand them. Make software builds with continuous integration. Apply configuration management, manage cloud servers, adopt automation for continuous delivery. Skills required to become a DevOps engineer. Now this is where I'll stop reading off of the slide and I'll quickly give you an example as to what do I do to give you more insights as to what would be expected. And please keep in mind that I've been doing this for 10 years. So the expectations from me are way too higher than what would be the expectations for you. Right? So if you ask me, Nishant, can you tell me what you do? Or how would you categorize the work that you do? In that case, my answer would be, I'll have 4 major categories for my work. So the first category would be infrastructure automation. I'll get to each one of them in a moment. So first category would be infra automation. Second category would be application deployment. Some people also like to call it release management. So the words don't matter as long as you understand what I'm talking about. So release management or application deployment. Third category would be logging and monitoring. And the fourth category would be communication. Now this is how I would be able to kind of divide the actual work that I do every day. Now let me give you a quick peek into what do I mean by each one of these things, right? So what do you mean by infrastructure automation? Now infra automation. Now think about what I said of the evolution of infra over the years, right? Now we are in an era where we work on a cloud, like with a cloud provider, and most of the things are containerized. Now in today's world, right, nobody has 2 servers. Nobody has 10 servers. Even if you're working for a medium-sized company, the chances are you have more than 100 servers. Although they would be very small servers. In majority of the cases, they would be like 4 gigabytes of RAM and 2 cores. Now, there is a very specific reason to have small servers. There is something called as horizontal scaling. So something for you to Google right after our webinar. So there is a purpose why these servers are kept so small intentionally. Google for horizontal scaling and you'll understand what I mean. But the question was infrastructure automation. What do you mean? So nowadays, nobody has 2 servers. Nobody has 10 servers. You will have more than 100 servers even in the lower mid-sized organization. The question is, how do you manage these servers? There are burning problems of things like, if I have 100 servers, do I really need those 100 servers? Do I know if I'm using more than 60% of RAM, which is also called memory, if I'm using 60% of memory of all those 100 servers? Because unless I'm using more than 60%, right, I don't even need those servers. For example, if your desktop, let's say you have a gaming desktop and you have 16 gigabytes of RAM on it, but whatever games you play does not require more than 2 gigabytes, of course, which is a preposterous statement, but let's assume that. So let's say you don't really need more than 2 gigabytes of memory. So is it even worth spending for that 16 gigabytes of RAM? It might be worth for your desktop experience. For server, it's a waste of money, right? So I need that visibility. How much of all of this am I actually using? Am I even using 60% of memory? Am I even using 80% of computing power that I have? Now that's where the problems start. If somebody is creating 100 servers, so the list of the problems will keep going on and on. So the problems like, if I'm creating 100 servers, how am I even supposed to create 100 servers? Do I log into AWS and I go create a server 100 times? Another problem would be, let's say somehow you manage to create 100 servers. Now who's going to prepare all of those 100 servers? You don't just create servers and start using them, right? You need to do basic things like operating system hardening, create user accounts for everybody in your team, maybe install the dependencies or applications that you have. Now these are big things. It's going to take you like 4 to 5 hours per server. So who's going to do it on hundreds of servers? Now that's where infrastructure automation comes into the picture. Anything from spinning up of the resources I'm using the word carefully, resources. I don't mean servers only. This would also include things like VPC, user accounts, servers, firewalls, databases, everything that you can basically think of. That goes under infra automation. So everything that I have to do from the moment that I spin up these resources to configuring them, to manage them, and to consistently maintain them after creating them will fall under infrastructure automation. Now there are different set of tools. To give you a few names, there are tools like Packer, there are tools like Terraform, there are tools like Ansible. Then there are alternatives to each one of these, like there is an alternative to Ansible, which is Puppet, and the list goes on and on and on. I can literally give you a list of 50 tools, but the point is, which one is useful to you? So that's the first thing that I do. The second thing that I do, or the second part of my job, is application deployment. So the same example. If my development team gave me a piece of code, I need to perform X number of processes on it before that application is actually deployed. And at the end of all of these processes, it is deployed in the production. Not only deployed, but also giving me the ability to roll everything back to the way things were before in case I don't like what is being deployed. So all of these things, when you automate them, is called an application deployment, or as some people call it, release management. Now there would be some fancy words like continuous integration and continuous deployment. These words might sound really heavy, but trust me, it's somewhat simple to understand if you are able to understand the concepts. Now for all of these, there are different set of tools. So there are tools like Git. Now Git is a code base. Like this is where people actually save their code. Git will let multiple people work on the same code at the same time, right? So Git acts like a code base and a version control system. Second tool is Jenkins. Jenkins is an orchestrator. Jenkins is more like your personal assistant. You can use Jenkins to automate everything in your environment. And then there are tools like Docker. Now Docker is the most popular packaging tool out there. So you can use Docker to actually package your application so that whenever you want to deploy it, you don't have to follow the same 10 or 15 steps every time. You do it once, and for every other time that you want to deploy it, it will be done automatically. Then there are tools like Kubernetes. So again, I'm simply giving you a few names here. There would obviously be more tools and more ideas and more concepts, but keeping or considering the constraint of the time, I can't really get into all of them, right? So this is more for giving you an idea. So these are like, this is a very usual stack. This is a very generic stack that people use to actually deploy the application. Then the third part of it is logging and monitoring. Now this is where people go like, logging and monitoring, how difficult could it be? You would be surprised to know that out of every task that I do every day, this is by far the most challenging problem. Not for me, for the entire world right now. Because imagine this, you have an environment of 400 servers, right? Now, all of those servers will have 10 different kinds of logs. All of those would have something called as operating system logs. They will have networking logs. They will have authentication or security logs. And then they also host their application, right? So they would have application logs, they will have API logs, and the list goes on and on and on. I can basically give you a list of 20 different logs. So the question is, 100 servers, 10 logs, meaning 400 log files. Did I do the math right? Sorry, 4,000 log files. 4,000 log files. How do you even read the logs from 4,000 files? Like you can't log into server individually and certify that this server is fine. Can you do that when you have 400 servers? You can't. So you need some solution for this. Now this is where logging and monitoring comes into the picture. Trust me, I've worked with different companies. What happens is people start looking out for solutions for this, right? Somebody comes up and says, hey, why don't you use something called as Prometheus and Grafana? It's a really good stack and it would solve all of your problems. So they go like, they look at the tool and they go like, yeah, you know what? It looks really good. Why don't we use it? So they start using Prometheus Grafana. 6 months down the line, they figure out, Prometheus and Grafana does solve our problem, but there are these 3 things that are still not happening with it. Can we use something else to fix them? Somebody comes up and says, hey, why don't you use something called an ELK stack? And then the entire company goes like, hey, yeah, ELK looks really promising. Can we solve those 3 problems with ELK? And everybody's like, yeah, new tool, let's do it. 6 months down the line, this goes on and on and on, and in a year, the same company ends up with like 10 different tools, and now nobody knows what tool is solving what problem. And managing those tools becomes a headache. Now, the problem is, can I remove like this tool? I don't know what application is using this tool, but at the same time, I don't know what's gonna happen if I remove this. Is it gonna break my environment? And that's the worst case scenario. That's the worst position for you to be in. So logging and monitoring, while it sounds really simple, this is the most challenging problem in today's world. And to give you an idea as to how we actually solve this problem, right? Imagine the same thing. You have 400 servers and you want a centralized location to actually get a visibility into all those 400 servers. Now, for logging and monitoring, there are different stacks of tools. You don't have an individual tool, there are stacks of tools. So the first and one of the most popular stack is ELK. So in case of ELK, E stands for Elasticsearch. Some of you might have heard of it. L stands for Logstash, and K stands for Kibana. Now what it does is, let's say this is your centralized location. This is where you want to visualize all of your logs. So what Logstash does, Logstash is a log transporter. So it will pick up all 10 logs from each and every server like all day, and it will keep transporting them to your centralized location. Now if I have 4,000 files being updated in this centralized location, again, I have the files now, but how do I read the logs? How do I get visualization as to what's going on in my environment? That's why you have Elasticsearch. So Elasticsearch is basically a data warehouse. Elasticsearch works on JSON, if you know what JSON representation means. So it can basically ingest all of those logs in JSON. So Logstash to transport the log, Elasticsearch to actually store the logs as a data warehouse. Then Kibana. So Kibana acts as a web GUI on top of Elasticsearch. So Elasticsearch actually stores the data, and Kibana will give you like a website as a wrapper around it. So you can actually, you can construct the queries and see what's going on. So that's one stack. Another famous one is Prometheus and Grafana, where Prometheus acts as the underlying data warehouse and Grafana acts as the GUI. So, to make your life easier. If you want to take a quick look, at their screenshots, all you have to do is Kibana screenshot. Kibana screenshot, right? You look at like one of those screenshots. Let me pick up the one that looks fancy, to leave an impression on you. Look at this. Now the one that you see on right, that's what Kibana looks like. So it's a GUI. You can decide what you want to see in it. It's completely modifiable. And then there's also something called as Grafana. Grafana screenshot. If you look at this, this is what Grafana looks like. So you could be reading the logs from like thousands of servers, but it makes it really easier for you to visualize. It gives you what you are interested in, right? So like all of those things are what I do. Now obviously I'm not the only one. I have a team where people excel in some of those focused areas. Like personally, I would consider myself to be really good at infrastructure automation, where because I've been doing this for 10 years, I can do pretty much everything that I talked about, right? So that is what a life of DevOps looks like. There is no set in stone. Majority of the times, you are the one that's solving the problem. Implementation is the other part. Now, there is a really big gap in these two words. A lot of people, what they expect is, I will just be doing what people told me. Now, if it's your first job or if it's your second job, that's what you can pretty much expect. Somebody who's been doing it for a while will tell you that, we have this problem, this is how we want to solve it, and here's how you solve it. Can you do it for me? So that's what you will be doing. After a couple of years, it becomes your responsibility to find out the solution. So in majority of the cases, you have to try out different things in order to settle on the things that solves your problem, which is what makes this job all the more interesting and challenging, because you get to learn 50 different things. Trust me, any one of you, tell me any stack that you're working on, and the chances are I would already know what the problems are and how do you fix that. Because of the exposure that I've received, I'm not saying that I know everything, but basically at some point in time, I'm pretty sure I would have come across that problem with some company that I was working with. I hope it kind of makes sense, right? it started from the very first page. Sorry about that. Yeah, so that's what the life of DevOps looks like. Now, I've given you a lot of information, right? I've given you basically a gist of what my career or the people that I know who are in really good places in DevOps, their career looks like. Now, I don't want to scare you off by the name of the tools. All those 4 categories that I showed you, it will take a while. It's not something that is expected on the day one. So if it's your first DevOps job, it's not like people are going to tell you, hey, can you monitor those 100 servers? Can you deploy these 5 applications? That's not how it works. It will go like, it's a series of natural growth. So your primary, I'll tell you what. So all those 4 categories, infra automation, application deployment, logging and monitoring, communication, I already told you what do I mean by communication, right? Infra automation, this is not something you can learn in a month or 2. It's just not possible. Doesn't matter how good you are. Infra automation actually requires you to have worked in a production environment to understand what kind of problems do you face. It will actually, grow you individually to make you comfortable with those problems. So this is not something somebody can teach you. I can show you the basics. I can show you how the tools work, how the tools solve those problems. But to call yourself really good at infrastructure automation, this will need some time. It's not something that takes 1 month of, somebody mentoring you. Application deployment, on the other hand, application deployment is something that can be taught. I can teach you what a code looks like, because in that case you don't really need experience with the code. You need to understand what do you do with the code once you receive the code. So this is something that you can learn. So the tools like Git, Jenkins, Docker, blah blah blah, so on, there are like 8 to 10 tools. These are the tools that I can help you make sense of, because this is something that you can learn in a month or a month and a half with focused effort. Logging and monitoring, again, not something that you can learn, because the prerequisite of logging and monitoring is that you understand your infrastructure really well. If you don't know infrastructure, how are you going to monitor it, right? Communication, it's natural. So some people are really good communicators, some people need some time to grow themselves. But out of all of these things, right, application deployment is something that you can learn. And application deployment is pretty much an entry point to get a job. If I received your resume, right? So I do a lot of interviews, and let's say somebody sent me your resume. Nishant, can you look at this? Do you think this guy is a good fit for us? So let's say I'm scanning through your resume. I see that you worked as a, let's say you worked as a developer, you worked as a tester. In total, you have 5 years of experience. And then you're telling me that in your resume, you say that you're really good at Ansible. I would not believe that, because if you worked as a tester, right, there is absolutely no way that you know what production environment, what are the issues in production environment. So there is no way you can excel this. What you can excel is application deployment. So if I was looking at your resume, even if you haven't worked as DevOps before, but if it says you worked as a tester, or if you're completely fresher, but you know how Jenkins works, how Git works, you show me a couple of things that you've done. Nishant, here's a GitHub repo. This is what I've done in my free time. This is the side project that I was working on. I would really be impressed. So this is the entry point for a job. In today's world, people are looking for people, or the companies are looking for people who can help them with application deployment. There are more senior people available for infrastructure automation, but that's not something you get to do on the very first job. That's something that happens with time. So this is where the course is focused on. Like the entire course, the organization that organized this entire webinar, the course is completely focused on application deployment, because this is something you can learn in span of like a month. If it's a really focused effort, then 20 to 25 days. When I say focused, I mean really focused. No phone, no news, no other distractions. You're purely you're purely focused on what is it that you're trying to learn. Cool. Now this is the course curriculum. I don't want to be the one to talk about it, but I'm pretty sure you do have your contacts at MICS. So this is all that I wanted to cover. I'm pretty sure a lot of you would have a lot of questions depending on the backgrounds that you guys have. So if you have any questions in general, or if you have any technical questions, any kind of questions, I will be happy to take them. Now is the time to ask them. All right, so I'm not really getting any questions, so I think I want to take that as you guys like what I presented. So that was pretty much, okay, one question is, can you share the PPT? Right, so my colleague who's a part of this webinar, he'll let you know shortly. What else? All right, cool. So let's just wait in case everybody has any questions. Should I need to tell about your benefits? Okay, interesting. Got a lot of information from this webinar. Well, I'm glad you found it interesting. It's kind of difficult to keep people interested when you're presenting something. Trust me, I've been a part of webinars before, like not as a speaker, but as part of the conferences. And if you don't really talk on point, or if you don't really have anything interesting to say, people get bored really fast, specifically in today's world where attention spans are really small. Right, so there are a couple of questions about the session and the course. I'll let my colleagues answer those questions for you.
Hello. Hello everyone, then I can help you about all your queries. So this training cost almost 5 weekends. If it is weekdays, it costs you 18 to 20 days. So the certification course, you have the benefits right now, you know, like one complimentary course we are providing. Apart from this, you are getting some 20 to 25% discount. So once you are interested, we'll just give a call, just drop down your details, then we'll call and we'll help you all the details. Cost, so how many days it takes to complete this program, what are the real-time projects you have to work, so how to work on those real-time projects. So every details will help you. And you have the lifetime access too. So once you enroll this course, there is a lifetime access. So after complete your course, what are the doubts you have, you can clarify, raising your tickets. And then you have the class recordings, the 2 types of teaching modes you'll get it. And this is a mostly instructor-led training. So as if you know, like you have that idea right now how the classes is running. And 24/7 customer support you have. If you face any problem, at any point of time, you can raise the ticket and you can clarify your doubt. If anyone interested about to enroll, just please drop down your details and we'll help you with that, all the details. Thank you, Ravi. I'll just get back to you, okay? Okay. Thank you, Nishan, and all our participants. You will receive a survey asking for feedback on this event. Your insights will help shape future events such as this. We will send you a link to the recording of this event so that you can share it within your social networks. On behalf of Magna Infotech Career Services, thank you for joining us today. We hope you found this information and dialogue valuable in enhancing your understanding on DevOps. If you are interested to know more on this topic, do check out our courses on Magna Infotech Career Services portal, mscs.magna.in. We sign off and wishing you all a wonderful day ahead. Thank you.